Welcome everyone to today's mind-blowing episode. We're diving into what I fondly call the new eye on the universe, the James Webb Space Telescope, or JWST. Imagine this. While most of us were unwrapping Christmas presents in 2021, an incredible piece of technology was blasting into space, ready to unlock cosmic mysteries. It took 3 decades to develop and cost approximately $10 billion, all to ensure it could settle into its orbit, nearly 1.5 million kilometers from Earth.
Wow. $10 billion? That's like a whole fleet of football stadiums worth of technology. So what really makes this telescope so special compared to, like, all the telescopes we've had before? I mean, was it built by wizards or something?
Great question. The JWST is groundbreaking primarily due to its advanced infrared capabilities. Imagine this. The universe emits light in so many different forms. And JWST? It's like a superhero that can see perfectly in the dark, with its primary mirror measuring 6.5 meters in diameter, made of 18 segments coated with gold to reflect about 98% of infrared light. BI can detect distant galaxies and even the atmospheres of exoplanets.
Huh, that's really cool. So, it's like having a cosmic detective on the case. I'm curious, what sorts of things has it actually found? Like, have there been any mind-blowing discoveries that made scientists jump out of their seats?
Absolutely. When it comes to mind-blowing, one of the most stunning discoveries was the galaxy Glasmy 13. It exists just 300 million years after the Big Bang. Can you imagine that? That's like finding out that a dinosaur was around when Klingons roamed the universe. This discovery challenges what we thought we knew about how galaxies formed.
Whoa, that's wild. So, like, why did scientists think galaxies couldn't form that early? Was there some cosmic rulebook they were following?
Exactly. It's like unearthing treasure in a place you assumed was barren. Before JWST, many scientists believed it took a considerable amount of time for these massive structures to develop after the Big Bang. Now, with the data from the telescope, we see that galaxies were actually forming much sooner than we anticipated.
That's mind-blowing. What else has JWST spotted? Has it found anything from other worlds, like maybe alien planets or even, spaceships? I mean, that would be wild.
Laughs. No, unfortunately, no spaceships yet. But we've identified some really intriguing exoplanets. For instance, JWST detected carbon dioxide in the atmosphere of a planet called LHS 475b. And it also found methane and dimethyl sulfide in K2 to 18b, which could hint at potential life. Plus, it mapped the 3D temperature profiles of an exoplanet, revealing its atmospheric features in remarkable detail.
So, it's basically scanning for cosmic signs that we're not alone? That's amazing! But, how exactly do they figure out what's in these distant atmospheres? Do they just, like, taste the air or something ridiculous?
Chuckles. I wish it were that simple. They use a technique called spectroscopy, which is somewhat poetic when you think about it. It's like reading a person's feelings by observing their outfit. Certain molecules absorb and emit light at specific wavelengths. By analyzing light passing through an exoplanet's atmosphere during its transit, scientists can determine what elements are present.
Wow, that's kind of poetic in a nerdy way. What about star and planet formations? You mentioned that earlier. Could you elaborate a bit more on that? Sounds super cool.
Of course! One of JWST's most iconic images showcases the pillars of creation, vast columns of gas and dust acting as nature's nursery for new stars. Additionally, it revealed dust rings around the young star Fomalhaut and detected water ice in the disk of TW Hydrae, which can serve as building blocks for new planets.
So it's literally photographing when stars decide to pop out, like, babies in a cosmic maternity ward? That's incredible! But, it sounds like a massive operation. Did it face any significant challenges?
Absolutely. The telescope faced risks from micrometeoroid impacts, which caused some damage. However, JWST has exceeded expectations, delivering breathtaking images with greater clarity and fuel efficiency than we had anticipated.
That's like facing a storm at sea and still managing to sail your ship smoothly, right? What do these discoveries mean on a larger scale? Are we talking about a philosophical shift in how we see ourselves in the universe?
Absolutely. The findings from JWST challenge our anthropocentric viewpoint. Discovering ancient galaxies suggests that if life exists elsewhere, it may have developed long before Earth appeared. This raises profound questions about our existence and the ethical implications of our explorations in space, especially considering how light pollution from satellites affects observations.
Wow, that's heavy. It's like a whole philosophical revolution for humanity. What's next for the JWST? Are we just scratching the surface of its capabilities?
Precisely. Future priorities include exploring exoplanets in the habitable zones of TRAPPIST-1 and tracking dust from supernova SN 1987A. Collaborations with upcoming telescopes like the Extremely Large Telescope will further enhance our ability to observe exoplanet atmospheres deeply and unlock even more cosmic secrets.
It really feels like we're on the brink of a sci-fi novel where we discover a whole new chapter in the book of the universe. So in a nutshell, the JWST isn't just a telescope. It's a revolutionary tool reshaping our understanding of the cosmos and bringing us closer to uncovering alien life. What a thrill!
Exactly, and I think that's a brilliant note to wrap up on. The JWST is opening doors we didn't even know existed, and this is just the beginning of our incredible cosmic journey.
I can't wait to see what comes next. This has been an eye-opening conversation. Thanks so much for breaking it all down for us.